Some winters arrive with biting cold, icy winds, and blankets of snow, while others pass by with surprisingly mild temperatures and barely a dusting of frost. Sometimes, the ground stays dry, and the air feels unseasonably warm, leaving many to wonder what's behind these dramatic shifts, from year to year. The answer often lies far from our own backyards, in the vast expanse of the Pacific Ocean, where subtle changes in water temperature and wind patterns can set off a chain reaction that affects weather across the globe. Recently, scientists at the Climate Prediction Center have made an important announcement. La Niña, a climate pattern known for its powerful influence, is making a return. This recurring phenomenon can dramatically shift weather patterns, not just in the United States, but all around the world, altering everything from rainfall to temperature extremes. La Niña is a natural part of Earth's climate system, cycling in and out every few years. It's the counterpart to El Niño, and together, these patterns are known as the El Niño Southern Oscillation, or ENSO. The arrival of La Niña is a signal for meteorologists and the public alike to pay close attention, as it often brings a wave of changes that can impact agriculture, water supplies, and even our daily routines. For some regions, La Niña can mean an early and intense start to the snow season, with colder temperatures and heavier snowfall than usual. Perfect for winter sports, but also a challenge for travel and infrastructure. In other areas, it might bring drier conditions, raising concerns about drought, water shortages, and the health of crops and livestock. Farmers and communities must prepare for the possibility of less rain and more stress on water resources. In this video, we'll break down what La Niña is, how it forms, and why it has such a powerful effect on our weather. We'll also look at how scientists study these patterns and what their predictions mean for you. To track La Niña, experts rely on a network of satellites orbiting high above Earth, ocean buoys that measure temperature and currents, and advanced computer models that simulate the atmosphere and oceans. These tools allow scientists to monitor changes in real time, analyze vast amounts of data, and provide early warnings to help communities prepare for what's ahead. The return of La Niña is a powerful reminder of how a shift in ocean temperature, sometimes just a few degrees, can ripple outward, triggering weather changes thousands of miles away and affecting millions of people. We'll explore how this giant engine in the Pacific sets the stage for new weather patterns, pushing storms, droughts, and temperature swings in unexpected directions. Whether you live in the snowy north, the rainy west, or the dry plains, La Niña's influence can be felt in your region, sometimes subtly, sometimes dramatically. By the end of this video, you'll have a clearer understanding of how this global phenomenon shapes the weather you experience every day, and how staying informed can help you adapt to whatever the season brings. To understand La Niña, we head to the equatorial Pacific Ocean, a vast expanse of water that stretches thousands of miles across the globe. This region is not just a beautiful blue stretch on the map, it's the engine room for some of the world's most important climate patterns. Here, in these warm and seemingly tranquil waters, the story of La Niña begins, setting the stage for a global climate phenomenon. The name La Niña means the little girl in Spanish, but don't let the gentle name fool you. It's marked by cooler than normal ocean waters in the central and eastern Pacific, a shift that can have powerful consequences. This cooling of the ocean's surface sets off a chain reaction, sending ripples through the atmosphere and affecting weather patterns all around the world, from the Americas to Asia and beyond. La Niña is one phase of a larger climate cycle called the El Niño Southern Oscillation, or ENSO. ENSO swings between warmer El Niño and cooler La Niña phases, each with its own unique impacts on global weather. The main driver behind La Niña is the strengthening of the trade winds, steady winds that blow from east to west across the Pacific. These stronger than usual winds push warm surface water toward Asia, allowing colder, deeper water to rise up along the coast of the Americas. This process is known as upwelling, and it's crucial for the development of La Niña. As a result, a vast stretch of the Pacific becomes noticeably cooler. Scientists keep a close eye on a specific area called the Niño 3.4 region, where these temperature changes are most pronounced and easiest to measure. When the sea surface temperatures in this region remain below average for several months, meteorologists officially declare a La Niña event. Careful monitoring and data analysis are key to making this call. The cooler water doesn't just stay in the ocean, it chills the air above, shifting air pressure and disrupting normal patterns of rainfall and wind. This can mean drier conditions in some places and heavier rains in others. It's like adjusting a giant planetary thermostat, with even small changes in ocean temperature having far-reaching effects on the atmosphere. These changes ripple outward, influencing weather in North America, South America, and even as far as Africa and Australia. The effects can be seen in shifting storm tracks, altered monsoon seasons, and changes in hurricane activity. Next, we'll explore how this seemingly simple cooling of the Pacific can lead to dramatic weather changes, causing floods, droughts, and storms across the globe, and shaping the climate in ways that touch us all. La Niña's cool Pacific waters have a powerful effect on the atmosphere, especially the jet stream. The jet stream is a fast-moving river of air high above us, steering storms and weather systems. During La Niña, the jet stream shifts farther north over the U.S. This northward move changes the boundary between cold northern air and warm southern air. As a result, the northern U.S. gets more cold air and storms, while the south is left warmer and drier. This split is a direct result of the jet stream's new path. Meteorologists use this predictable shift to make more accurate long-range forecasts. Knowing where the jet stream will flow helps us anticipate which regions will be colder, warmer, wetter, or drier. It's the critical link between Pacific waters and the weather in your backyard. La Niña's northward jet stream creates a clear weather divide across the U.S. The northern tier, like the Pacific Northwest and northern plains, gets colder, with more frequent blasts of Arctic air. Meanwhile, the southern half, from California to the southeast, is left under high pressure, leading to warmer, drier conditions. This temperature split is a classic La Niña signature, seen in past events. Northern states may face higher heating bills and more snow, while the south enjoys milder weather but risks drought. These are general patterns. Day-to-day weather will still vary. But overall, La Niña winters bring a predictable north-south temperature divide. This helps communities and energy companies plan for the season ahead. La Niña doesn't just affect temperatures, it also shifts where rain and snow fall, creating dramatic changes in weather patterns across the United States. This phenomenon is driven by cooler-than-average sea surface temperatures in the central and eastern Pacific Ocean, which set off a chain reaction in the atmosphere. The jet stream, a fast-moving river of air high above the Earth, is pushed northward and then dips south in new places. This altered path brings more frequent storms and increased moisture to regions like the Pacific Northwest, the Midwest, and the Great Lakes, making these areas much wetter than usual. These regions often see above-average precipitation, with heavy mountain snowpack in the northwest. The extra snow not only impacts winter recreation and travel, but also helps replenish water supplies for the coming year. The jet stream dips southward over the Midwest, pulling in warm, humid air from the Gulf of Mexico. When this moisture collides with cold northern air, it creates the perfect setup for powerful storms, heavy rainfall, and even severe weather outbreaks. This can mean beneficial rain for agriculture, helping crops grow and replenishing soil moisture. But it also raises the risk of flooding as rivers and streams can quickly overflow, threatening farms and communities. Meanwhile, the south dries out as storms bypass the region. Places like Texas and the Gulf Coast can experience drought, with parched landscapes and shrinking water supplies becoming a real concern. La Niña brings feast to some areas and famine to others, creating a stark contrast between regions that are drenched and those that are left dry. Residents in wetter zones should prepare for more rain and possible winter storms, taking steps to protect their homes and stay safe during extreme weather events. The repositioned jet stream redistributes the nation's rain and snow, acting like a conveyor belt that moves moisture from one region to another, sometimes with little warning. It's a striking example of how one climate pattern can reshape the country's weather, reminding us of the powerful forces at work in our atmosphere and the importance of staying prepared for whatever nature brings. While the Midwest gets wetter, the South faces a different story: drought. La Niña's northward jet stream leaves the southern U.S. under high pressure, suppressing rain and cloud formation. This increases the risk of drought, with dry soils, shrinking reservoirs, and stressed crops. Drought can impact farming, ranching, water supplies, and even increase wildfire risk. Cities may need water restrictions to conserve limited supplies. Southern dryness is one of La Niña's most concerning effects, especially for areas already short on rain. Communities must be mindful of water use and prepare for a prolonged dry spell. The current forecast is especially troubling for places like Southeast Texas, already facing a rainfall deficit. Southeast Texas, including Houston, is already in moderate drought, and La Niña threatens to make it worse. The region has a significant rainfall deficit, with Houston missing about 10 inches of rain this year. October brought just 1.77 inches, far below normal. Dry soil and low water supplies make the area vulnerable to La Niña's dry pattern. Prolonged dryness could impact everything from local ecosystems to home foundations. Authorities may need to manage water resources carefully if the dry spell continues. La Niña's arrival amplifies existing problems, showing how global patterns have real local impacts. La Niña also affects the Atlantic hurricane season by lowering wind shear, which makes it easier for storms to form and strengthen. Seasons with La Niña often see more hurricanes and major storms. However, timing matters. This La Niña arrived late in the hurricane season. Most storms had already formed under different conditions, so the impact this year is limited. If La Niña had developed earlier, the season could have been much more active. As the season ends and ocean waters cool, the risk of new storms drops. Forecasters will keep watch, but the main concern now shifts to winter weather patterns. La Niña's biggest influence this year will be on temperature and precipitation, not hurricanes. This La Niña is expected to be brief, likely ending by November. Afterward, we'll return to an ENSO-neutral state, neither La Niña nor El Niño. Neutral periods mean the Pacific has less influence, and other factors drive our weather. A short La Niña is good news for drought-stricken regions, as the dry pattern may not last long enough to cause severe problems. The hope is that neutral conditions will bring the storm track back to normal, offering relief to places like Southeast Texas. La Niña's return has shaped our weather, but its short duration offers hope for a more balanced winter ahead. As the Pacific influence fades, we may see a return to more typical weather patterns. Stay tuned and stay prepared as the season unfolds.